Is your cloud database running like a sports car, or is it stuck in heavy traffic? Moving to Azure SQL is amazing, but the cloud doesn't automatically fix your performance problems. You still have to tune the engine. Welcome to the EA Strategy Masterclass on database optimization, presented by NonTechieGuide. In this comprehensive, layman-friendly guide, we break down the complex world of Azure SQL performance, tuning into 5 easy-to-understand modules. Whether you're an aspiring Azure Database Administrator preparing for the DP-300 exam or an enterprise architect looking to streamline operations, this course has you covered. Moving your database to a cloud library like Azure SQL doesn't mean you can ignore the chores. That is false. Your database administrator remains essential for the digital housekeeping needed to keep the system healthy. A well-performing database starts with index maintenance. Think of it like a disorganized textbook index that must be rebuilt or reorganized by the DBA for quick data retrieval, preventing slow data crawls. Next is statistics maintenance, which acts as the database engine's optimizer map for the fastest possible routes. While outdated stats create terrible routes, up-to-date statistics act like a GPS, ensuring massive benefits for query speed. Finally, always be vigilant against data corruption, a digital nightmare caused by microscopic hiccups in physical hardware. To counter this, the DBA must schedule their own regular internal integrity checks, the DBCC CheckDB, to guarantee your data is perfectly safe. For decades, self-tuning databases failed due to amnesia upon restarting and blindness to long-term performance. Azure SQL finally solved this using perfect monitoring and the query store, a digital flight data recorder with long-term memory. Operating under the golden rule to do no harm, Azure utilizes a triple power approach, forcing faster historical plans, creating helpful indexes during quiet hours, and automatically dropping unused ones after 93 days. Switch to AI Autopilot and boost your performance today. No matter how intelligent your database software is, performance is ultimately limited by your storage foundation. In the cloud, you do not buy physical hardware. You rent virtual slices of massive storage arrays called managed disks. You must carefully balance blazing speed against your budget, choosing from top-tier Ultra disks down to standard backup drives. Because Azure SQL operates on shared physical machines, you rely on database-scoped configurations. This allows you to safely adjust specific engine settings without ever disturbing your digital neighbors. Imagine a busy restaurant where one massive party demands all the waitstaff, leaving your VIPs completely ignored. Your database faces this exact same problem. To fix it, SQL Server uses the resource governor to act as a traffic cop, slicing your database's power into distinct resource pools. You can set minimum protections to guarantee computing power when it is needed, or maximum ceilings to prevent any one group from hogging the system. Finally, a lightning-fast classifier function acts as the bouncer, instantly checking users at the door and routing them to their proper pool, ensuring everyone gets fair and fast service. The ultimate superpower of the cloud is elasticity, the magic ability to shape-shift your database by expanding when busy and shrinking when slow, so you only pay for what you need. When scaling your virtual machine, you can choose general-purpose servers, high-speed bandwidth machines, or save a fortune on licensing with constrained cores. But the real magic is intelligent query processing. By adapting memory limits, waiting on temporary data sizes, and remembering multiple strategies, your database actually learns from its past mistakes and gets smarter over time. We built our cloud database foundation by carefully selecting the right managed storage disks and isolating our configurations. Then we tackled our daily digital chores as our database administrator rebuilt fragmented indexes, updated routing statistics, and checked for data corruption. Once organized, we activated the self-driving database, allowing Azure's query store to automatically and safely tune our plans. We also acted as a traffic cop, utilizing the resource governor to fairly distribute computing power and prevent resource bullies. Ultimately, we elastically scaled our virtual machines and unlocked intelligent query processing, which allowed our database engine to adapt, learn from its past mistakes, and achieve optimal performance.